All right, guys, good morning. Can I get a thumbs up that you hear me and see the presentation okay? Okay, well, guys, on Friday, we saw how to solve a quadratic equation using square roots. I want to give you guys another day to practice that, so I'm going to go over a few more problems with you, and then tomorrow, you're going to learn the last way that I teach you how to solve a quadratic equation, right? So far, we've taken a quadratic equation and we've solved it by factoring. Then we took a quadratic equation and we solved it using square roots. There's another way to solve a quadratic equation, and it's called the quadratic formula. Guys, the problem when you solve a quadratic equation by factoring is that not all quadratics can be solved that way, because not all quadratics can be broken up into these beautiful whole number factors, right? So then we have square roots, but square roots can only solve the quadratic equations that don't have an x term. So right now, the two ways that you solved or learned how to solve a quadratic equation, they can't solve all of them. So we still need another method. And the last method we learned is the quadratic formula, all right? But I wanted to give you guys one more day with these square roots before we go on to the quadratic formula. Once we learn the quadratic formula, then we're going to take a quiz on solving quadratics using any of these methods, okay? All right, here we go. So guys, if you're going to solve a quadratic equation using square roots, remember, there can't be a just x term, because I'm not going to be able to unsquare just x with a square root, all right? So here are the steps that we follow. You want to get the x squared term, or sometimes it's a parenthesis squared. You want to get it completely by itself on one side of the equal sign. Then you want to take the square root of both sides. You don't want to forget the plus or minus sign, because remember, you should be getting two answers to a degree 2 quadratic equation. And then you always want to simplify your answer if possible. If any of these square roots can be simplified, we want to do that. Oh, I can take my mask off. There's nobody here. I always forget. All right. So now, here we go. So guys, look what I said the directions are to this one. I said find the x-intercepts or zeros. Zero is just another name for an x-intercept. It's called a zero because it's the x value that made the equation equal 0. All right, so 0, x-intercept, they mean the same thing. All right, find the x-intercepts of the following quadratic equations by solving each equation for x and using square roots. The reason I put these directions is because I want you guys to always remember, well, what are we even solving for when we solve all of these equations for x? Guys, we're solving for the x-intercepts of its graph. These are the x values where his parabola will cross over the x value. Because every year some students are like, I don't even know why we're doing this. Why do I care what x is? We care because it's an important point on his graph. It is the x value where it will cross over the x-axis. Okay? So when we solve all of these equations for x, that's what we're finding. All right, let me move it up and then we'll get started. All right, so guys, let's solve this quadratic degree 2 equation for x, right? Well, I noticed this is one of those ones where it's not x who's squared, it's this entire parenthesis that is squared. So that's okay. Our job is to get that parenthesis squared by itself. So the 72 and the negative 2, they got to go. So we're going to get the 72 away first by subtracting it. Just normal solving equation rules, right? Get the one that's not attached away first. Then you end up with negative 2 times x minus 7, the quantity all squared, equals negative 72, right? Well, to get rid of the negative 2, you are definitely not allowed to distribute, because PEMDAS would definitely tell us to square before we multiply. So you are not allowed to distribute this negative 2. The only way to make him go away is to do the opposite of what he is being asked to do. And since he's being asked to multiply, we have to divide him out. You have to divide him out. All right, and then you're left with x minus 7, the whole thing squared, equals positive 36. Okay, so guys, look, we're trying to find an x value, or x values, that when you subtract 7 from it and square it, you end up with 36 as your answer. So to find out what number that needs to be, we have to unsquare it. So square root both sides. Now that this parenthesis squared is by himself, let's unsquare it. So square root this, square root that. All right, this square and that square root cancel, and you're just left with x minus 7. And then it equals. But guys, there's definitely two different numbers that I could have squared to get 36. I could have squared 6. I could have squared negative 6. So there's definitely two answers to this when we're solving. So I get the positive or the negative answer. And what is the square root of 36? Thank the Lord, it's a nice number, it's 6. So it could have been positive or negative 6 that made this true. But the problem is, I'm not done solving for x, right? We have to continue solving until x is alone. So to do that, I have to add 7 to the other side. All right, so now x equals, now I really can't add 7 to this side yet because that's not really a 6. So I can't just be like, oh, 6 plus 7 is 13. Because really, this is two numbers in one. This is a positive and a negative 6. So all you can do is take that 7 and shove it in front of the plus or minus sign and create a little expression. And it says 7 plus or minus 6. Let me write that over here. X equals 7 plus or minus 6. So guys, to get your two answers, you have two scenarios to work out. One answer is going to come from when you take 7 and add it with 6. And then the other answer is going to come from when you take 7 and subtract it with 6. And then I'll get my two answers from these two scenarios. So x will equal 13 here, and x will equal 1. So those are the two x values that when you plug it back into this equation, it'll make it equal 0. These are the two x values where his graph would cross over the x-axis. Guys, this parabola would cross the x-axis when x is 1 and when x is 13. And since the number in front, if you remember vertex form of a parabola, is negative, the parabola would have went down. So that's a little sketch of what his graph would have looked like. All right? But those are definitely the x values where it crossed the x-axis. All right? How did that feel? Is everybody okay? Everybody good? All right, I'm going to give you guys a head start on the next one. I'll let you guys get started, and then I'll try to catch up. Guys, notice in this one, it's not the parenthesis that's being squared. It's just x who's squared. So your job should be to get that x squared completely by itself so you can unsquare it. So you guys take a head start. I'm going to check the attendance while you do that. I just want to say this out loud. Right now, I'm missing Udelis. I knew Sophia was going to be out. Sarah Reeves, Larry, and Youssef. I'm just going to kind of join in as you guys go. The first thing I would have done was add the 9. Get that negative 9 away from there. Now, guys, when you go to get rid of the negative 3, this time, since it's not the parentheses that are being squared, you do have the option to distribute the negative 3 if you wanted to. But, guys, you're going to have to divide him out later just to go get x squared by itself. So I would just divide him out right now. Instead of doing negative 3 times all of this, just divide it by negative 3 and get rid of them that way. And then you don't need the parentheses anymore, and you have x squared plus 5 equals positive 23. But x squared isn't alone yet, so you still got to minus that 5 away. You don't want to take the square root too early. Then you get x squared equals 18. So you're trying to figure out what number or numbers could you have squared to equal 18. Well, guys, 4 squared is 16. 5 squared is 25. So we skipped over the 18. So clearly it's some decimal in between 4 and 5. But we don't want decimals because every time you take the square root of a number who you can't take the square root of, the answer is a really ugly, non-repeating, non-ending decimal. It's an irrational number. And we don't want that because then we'd have to round it. And when you plug a rounded answer into an equation, it won't make it true. It'll be like negative 77.9999999 equals negative 78, but it won't make it true. So we need the exact simplified answer. So let's take the square root of both sides to figure out what number, when you square it, you get 18. All right, so the square and the square root cancel. I'm left with x. But guys, remember, I could have squared a positive number to get 18, and I could have squared a negative number to get 18. So there's two versions of this answer, the positive number and the negative number. All right, and then what's the square root of 18? Can you take the square root of 18? We just said no. Can you simplify the square root of 18 though? Is there a perfect square, a number that you can take a square root of that divides evenly into 18? Yeah, 9. So we can break this up into the square root of 9 times the square root of 2. And now x will equal plus or minus, the square root of 9 is 3, and then we times it with the square root of 2, which is a simplified square root that we can't get rid of. So guys, one answer is when x is equal to positive 3 times the square root of 2, which again is just a really ugly decimal. And then the second answer is when x is equal to negative 3 times the square root of 2, which is just a very ugly decimal. So let me show you this just to give you perspective. So if you're like, all right, so his x-intercepts, the points that he crosses the x-axis at, are 3 times the square root of 2. If you're like, I have no idea what number that is, well, then you would ask your calculator, what is 3 times the square root of 2, so you could get an estimate as to what that is. But we don't want to write our answers as an estimate. These are the exact answers, and then let me show you. If you ask your calculator, what is 3 times the square root of 2, is that on the screen? There's 3 times the square root of 2. Hit enter, and it's about 4. This is terrible, I apologize. I can't get a glare. It's like 4.242640687. It just keeps going and going and going. It doesn't end, it doesn't repeat. It's just a really ugly decimal. But it's about 4.2-ish. And then that would be negative 4.2-ish if you had to, try to picture where that number is on an x-axis. But we don't want rounded answers because they won't make it true. Only the exact simplified answers will. Is everybody okay? Yep. All right, then I'm going to ask you guys start this last one, and then I'll try to join in a minute, and then you guys can start working on your homework. I wanted to give you one more day to practice this. Guys, I'm not going to lie. The answer to this one, it's ugly. It's like, what? That's my answer? Yeah, it ain't pretty in this one, but I wanted you to see an answer like this. Oh, that's still really hot. $20, yep. First thing I would have done is I would have noticed that this is one of those, the whole parenthesis is being squared. So your job is to get this whole parenthesis alone so you can unsquare that parenthesis. So I would at least add the 4 is where I would have started. Okay. When you go to the next step, when you want to get the 2 away, remember now, because this entire parenthesis is being squared, now you don't have the option to distribute because you would never multiply before you square. So we have to divide the 2 away. We do not have the option of distributing here. So divide by 2, get that 2 away from it. Okay. Thumbs up. Are we all on the same page? We're all getting the same answer so far? Excellent. You guys are awesome. Thank you for hanging in. All right, so now that this parenthesis is squared, now he's alone, I can unsquare it. So I'm going to, but guys, if you notice, there's a lot of stuff going on this parenthesis. Okay, that's fine. It just means we're going to have a lot of stuff left to do after we take the square root. So square root both sides. All right, this square and that square root cancel. I'm going to come over here, give myself room. All right, that's going to leave me with 5x minus 1 equals Remember, there's two different numbers that I could have squared to get 33 as my answer. I could have squared a positive or a negative number, so don't forget your plus or minus sign. Now, can you take the square root of 33? No, right? Nothing squared gets me 33. The square root of 25 is 5. The square root of 36 is 6. We jumped right over 33, so it's a decimal in between 5 and 6. All right? So now, ask yourself, can you simplify the square root of 33 though? Do any of your perfect squares like 4 and 9 and 16 and 25, do any of them divide evenly into 33? No, which is great. It means less work for us. It means he's already a simplified square root and we can leave him just like that. So it's plus or minus the square root of 33. All right. So it's kind of like a win and a loss. It's a win that we got this whole square out of the way, but guys, we still have a lot left to do until x is alone and we have solved the problem. So what are we still going to do? Like normal, to get x by itself, we got to get the negative 1 away first, so add 1 away. All right, and you're left with 5x equals. Now guys, I can't really add 1 to the square root of 33 because number one, the square root of 33 is a really ugly decimal. I don't want to add 1 to it because I don't want to round it. But it's not just the square root of 33. It's the positive and negative version of the square root of 33. It's two numbers in one. So again, I can't add it to it yet. All I want to do is shove that 1 in front of the plus or minus sign and create that little expression. All right, so put them right in front, and you're going to get positive 1 plus or minus the square root of 33. Now again, because I can't take the square root of this number and get like a whole number, like if it was the square root of 36, we'd put 6. But since I can't take his square root, we just leave it. And we just leave it as 1 plus or minus the square root of 33. I don't want to actually add them together and round that. All right, and then here's the even uglier part. I still don't have x alone. Now I got to divide by 5. So divide this side by 5, and then divide all that by 5. So x will equal 1 plus or minus the square root of 33, all divided by 5. So guys, one answer is when I take 1 and I add it with the square root of 33, and then divide it all by 5. And then my second answer is when I take 1 and I subtract the square root of 33 and then divide it all by 5. So guys, you're going to end up with answers that look like this. You're like, that's done? Yeah, because there's no simplifying left that I could do. I can't simplify the square root of 33. Therefore, I can't add it with the 1. Nothing in this problem divides evenly by 5, so I'm done. And these are your two separate x values where your graph will cross over the x-axis. So guys, if I asked you to graph them, I have no idea what number that is. So just ask your calculator, what is 1 plus the square root of 33? It's about 6.744, blah, blah, blah. It's a really ugly decimal. And then divide it by 5. And it's about 1.4-ish. About 1.4-ish. All right? And then what's 1 minus the square root of 33 divided by 5? 1 minus the square root of 33 divided by 5 is just like negative 0.9. I don't know if you guys can see that, but it's just a very ugly decimal that I don't want to round. So it's like negative 0.9-ish. All right? So again, when our answers are these ugly decimals, we don't want the decimals. So we leave them in their reduced exact form. And sometimes it's ugly. And I wanted you to see this because a lot of times when you're solving with the quadratic formula, you end up with some ugly answers like this. So I wanted you guys to see it before we did the quadratic formula. All right, can I get a thumbs up if you're okay with that? I know it's not pretty, but guys, that's your answer. Okay, those are the x values that will make this equation equal 0 and will make it cross the x-axis. All right, well guys, I made one more Delta Math homework assignment on solving by square roots. I think Friday's was 10 questions, this one's 8 questions, so it's a little bit shorter. So you have this homework on square roots that will be due tomorrow night at 11:45, and then tomorrow we'll get into the quadratic formula, the last way that you learn to solve a quadratic equation. And hopefully you remember it from Algebra 1, but who knows. All right, can I get a thumbs up? We're all good?